Welcome everybody. Today is Wednesday, August 4th in 2021, and this is the Get Smarter and Make Stuff podcast. Today we're welcoming to the show someone I've always enjoyed talking to. I've had the opportunity to interview her a number of times on the prior podcast, the Cognicast, that I used to do once upon a time. She actually was the host of that show as well, and so we've had a chance to chat many times, both on air, as it were, and off. She's a super interesting lady with a lot of really cool things to say every time I talk to her. I will sort of leave it at that, though, because I'm sure you'll understand for yourself in a minute what I mean. But I will welcome to the show Carin Meier. Hello, Carin.
Hello. I'm just so pleased to be on here with you.
Yeah, well, I'm very fortunate. I have many interesting friends. And when I sat down to do the show, I was like, well, let me scribble down a few people that I might want to, have on some of the early episodes. And your name certainly came very quickly to mind and was at the near up at the top of that list, which is why you're here on what will probably be episode 9, I guess, by this time this goes out. So
well, I'm honored to make the top 10.
Good stuff. We started with 0, so yes, you absolutely make the top 10 by either criteria. But of course, we have to index from 0, being who we are, right? Cool. Well, we've talked a little bit about this, but the show is organized loosely, I will say, around 2 concepts: getting smarter and making things, hence the name, or hence the show, I suppose, since the name came first. And like I said, you are somebody who pretty much every time I've talked to you has had interesting, insightful, quite often amusing things to say about those topics, and who I think has a pretty like your life involves those things in a fairly significant way. I believe that's fair to say about you. I believe you would agree. Is that accurate?
Sure.
Yeah, sure. Sure. I know, right? It does sound good, but no, I think it's really true. I mean, as an example, the first time that we did a show, I believe we talked about you making robots, which is a thing that you have done, maybe still do some of, or will do again at some point. And obviously that is an exercise both fascinating in both the manufacture of physical objects, but also in the sort of the intellectual, heavy lifting you've got to do to make all that kind of thing work. So great stuff.
Yeah, no, I wish I could. Well, I'm not quite ready to get back to it. I went through my robot phase, and then I kind of pivoted to kind of the getting into the AI and machine learning part of it again. But I do have plans really when I retire. I want to be known as, that crazy lady with too many robots instead of cats. We'll just put the robots in.
Maybe a robot cat or 2 thrown in.
Maybe a robot cat or 2. Yeah.
Well, I'm curious. I mean, I don't want to spend a lot of time on this because as you kind of said, it was a period that you're not kind of deeply exploring right now. But I think it's really interesting. It remains interesting. We've talked about it before. What about robotics grabs you, and what makes it the kind of thing where you're like, I definitely want to come back to this? Like, is there something?
I think it's really. I mean, I think with all programmers, you get kind of this, jazzed up feeling when you finally get something to run and you make something, right? Yeah, software. But I think with hardware, it just comes to life that much more. It's not only, hey, I got this program to run, but hey, I got this robot to move across the floor, and it's in like real life. It's reified code, which is just super cool, and it's also a lot more challenging. I mean,
yeah, I'm curious about that, right? Because I think one of the things that I've seen in talking to people about these subjects is, that people are very willing to heap praise on others in their sort of hobby fields. Oh, I'm just an amateur. Oh, I'm not a real woodworker. I've had, various guests say, when in fact they've made, beautiful or useful objects out of wood themselves. So you say it's harder. Do you think that's really true, or is it that because you haven't made it like your job, that you're just not able to spend as much time on it, and therefore it has that element of challenge to it? Or is there something about robotics you think that's inherently difficult compared to whatever you're comparing it to, presumably the work that you do as part of your day job?
Yeah. So I think it's inherently difficult just because of the mismatch between analog and computer programming. You've got all those real life variables that you've got to map onto this nice, clean software programming system.
Your programming systems are nice and clean?
Well, compared to the digital,
Gotcha,
I could write a function that says, move forward. But
right.
And that will execute, but the actual translation of that into moving a physical thing that's got gears and friction with the floor and might not have the screw turned in, there's like so many variables in addition to the code that it's a lot of complexity. And then you have the whole different field. And there's so much to know about that I am obviously not an expert, in electronics, mechanics. If you really want to build big robots, which would be super cool, you'd have to know like hydraulics, Then you'd have to know how to 3D print your things and machine tool this. So there's like so much more to making things that interact with the physical world.
Yeah, totally. I mean, I've been getting a little bit into machining myself, starting to, I've made an attempt. Actually, my YouTube channel is a rather humorous attempt I made at 3D printing pulleys, which failed, right? For totally analog reasons. It was exactly the kind of thing you're talking about, where the gullies in the teeth, between the teeth, were probably a few thousandths of an inch too shallow, and the whole thing just didn't work in a subtle way.
Well, didn't you, I seem to remember, didn't you have like a chair that you had like hooked up to a flight simulator? I mean, isn't that kind of the same thing?
It is. And so I brought you on to talk to you, but you just put a quarter in me. So I will go off on the G Seat a little bit, because it is a project I want to bring back up. And I think it's interesting to talk about the ways in which it didn't work, because I think it's relevant to what you were talking about. So the basic concept, for those that aren't familiar, is, so flight simulation is one of my hobbies, or has been one of my hobbies. I've actually kind of set it aside for the moment due to family demands not really being especially compatible with, jumping on the computer at 9 o'clock at night, flying a 3-hour mission, and then being too jazzed up to sleep for an hour and a half afterwards. But I did build this thing called start to build this thing called the G Seat, which I totally took from a guy named Bergeson. I'm afraid I've forgotten his first name, but you can go look for Bergeson G Seat and you'll see the amazing work he's done. And I thought I'll make my own little version of this. It's basically a chair that has kind of 2 movable flaps in the seat and then 2 movable flaps in the back, that's hooked into the computer, such that when the aircraft, say, accelerates in a forward direction, the flaps in the back would sort of collapse such that you would sink back into the seat, giving the sense of G-forces, hence the name G-Seat. And so I spent a good 200 hours building this thing, and got really into it, and it didn't work. And I'm pretty sure that I have only recently learned the things that would allow me to succeed. For instance, I was not using shielded cables that ran from the potentiometer that I was using down to the board. And so there's probably a lot of noise from the motor. And so learning how to properly shield cables and isolate ground circuits are things that I picked up from a project that I did more recently called the electronic lead screw, which is a electronic motor controller for my my metal lathe. And so I'll probably go back to it and carry those lessons in. But it's really interesting in the light of what you were talking about, because this is very much an analog circuit kind of problem. And I think you'll appreciate this. My attempted solution at the time, kind of before I gave up, for reasons I don't even remember anymore, maybe just too much effort put into it and too little time, but was to move from a potentiometer to a rotary encoder to do position sensing. Which is essentially transforming a analog problem into a digital one. Right? So like kind of the programmer's cheat. But of course, then I ran into problems with you have to be able to read those things really quickly unless you have dedicated what's called quadrature decoders for reading them and reading them on an Arduino quickly enough to make sense of something that could be. Anyway, it was a whole thing. I'm already falling back into the memory hole of details and boring everybody. But yeah, it was a really interesting project. And but it very much is to what you were saying. We're like making a thing move. Like when I actually, I think you were there. I brought it down to the Cognitect offices when we came down and did a get together, and I was playing around with it, and getting the motor to like spin when I typed into the computer was super, super cool.
Yeah, definitely. I just have this image of you trying to debug the flight chair and having it like go all the way back or
like yep that. No, the big one was overshoot. Like you would tell it to go kind of back to the middle, and it would go way forward and then realize it was too far forward, and then so it would just go just like sort of hammer you into submission. I mean, I was not generally testing. I never got to the point where I was testing it while sitting in it, because one of the things is the motors need to be power enough to lift you up a little bit, right, or for this thing to work. And so I was a little bit careful about all that, but yes, had quite,
you don't want any back
number.
Injuries.
No, that's right. Yeah, exactly. But I want to turn the conversation back to you. I by the way, this is a nod towards your really excellent job in being the host of the Cognicast after I'd left the company, and that you are. See, you made me talk about myself. That's good stuff right there. You should do a podcast. If you're not doing one currently, are you?
No.
You should. I think it'd be great. I would subscribe. But I do want to turn the conversation back to you. And so, like I said, this show is really open. We didn't sit down beforehand and say, "Hey, let's talk about this, and this." It really is. I just really enjoy, having a conversation with interesting people. And you certainly qualify. So, but we do have this sort of seed question, which is, talking about making and talking about learning. I am always torn on which one to start with. You can certainly take it to whichever one of those you want. But I'm curious, what are you learning, Carin, lately? What's been occupying your learning brain, if anything?
Yeah, so you've got your work learning brain,
sure,
and then your other personal hobby learning brain. Sometimes they mesh,
sure,
but sometimes they're more distinct. So at work, where I'm working as Reify Health right now, we're just going through an incredible growth stage. So there's like so much to do. Just to give you a quick background, we make software and services that help pharmaceutical companies and also the people that do the trials get those to run more effectively, because our founders realized that we have the technology now as humans to make cures for diseases a lot faster than we have time and processes to get them through clinical trials. So that's really the bottleneck. And we saw that, right, with COVID. And it doesn't just apply to that. It applies to like breast cancer, Alzheimer's, just all those horrible diseases that there's new potential cures in the pipeline that we could get them, the good ones, to people that much faster if we could improve that process.
That's awesome. I mean, I've said this before, but when I was looking for a job, I had a bunch of criteria. They were probably somewhat similar to yours. I wanted to work with a team of engineers who were, going to push me working with technologies that I enjoy. And one of the criteria was doing good. And I've actually talked on the show a little bit before about how I think that at Kevel we actually are, making the advertising world better. But I kind of what I had in mind at the outset was, stuff like cure cancer, right? Like the classic do good. And that's exactly the kind of stuff you're working on. So that's fantastic.
Yeah. So I guess going back to the learning, I love Clojure, and we're definitely doing a lot of Clojure, but I've been stretching my skills in areas of actually doing system stuff, like with Terraform and, building out pipelines. I'm on the data team. So we're looking and getting our data pipelines through so we can help do interesting stuff with like AI and machine learning and data warehousing and all that. So that's my kind of work stuff that I've been
Mm-hmm.
stretching my, and maybe it is a natural progression that you start off kind of like at the code level, and then your horizon just gets bigger, right? And you just start thinking of systems and pipelines, and I guess it's one natural progression. The other, because I've seen other people that can just dive down into like details, like nuance down to the networks, and so I guess it's any way you want to grow. I guess I'm growing systems way right now, which
Mm-hmm.
is nice. So on the other side of that, and the personal research area, I've always been kind of interested in AI and done a lot of research into it with following the deep learning and machine learning. But man, that stuff, it moves so fast. And to be honest, I've been a little frustrated lately with it because there just seems to be so much churn. I think there was a lot of big fundamental breakthroughs, maybe like 5 years ago, when deep learning was really new.
Mm.
But now it just seems to me anyway that there's a lot of churn on not as much breakthrough, but pushing it in the thing of, we've got this new model based off this other model, we've tweaked it to be 2% more accurate, or we've done this, if we get on the scale of Google, that nobody else can touch. I mean, nobody can get as much data as them. They've got this incredible new model, or OpenAI, that that's another area to talk about with their GitHub Copilot.
I know nothing about what you're talking about. I mean, I don't really follow machine learning. So
Okay,
what's
but
OpenAI?
okay, so OpenAI it was originally a company that did research on artificial intelligence and deep learning models with the aim that it was all going to be open. And they wrote, to their credit, they wrote a lot of research papers and made them public. But then, and I'm sure you kind of remember this, they released GPT-3.
Nope, but go ahead.
Okay,
Yep, go
so
ahead.
GPT-3 was the model that you could make chatbots or generate text that seemed to be human-like. And in a lot of the tests, it was really, really human-like. You couldn't, if you gave it a prompt and said, generate me an essay for my high school paper on George Washington, there would be, it'd be pretty good. And they, despite it being named OpenAI, they decided to not release the model and keep it closed source because they, quote, thought it would be too dangerous to release.
Gotcha.
And maybe that's true. Maybe that wasn't. But people could use it for, chatbots, disinformation on the web. However people want to evilly use that. So they kept the model closed source. And that was fine. That was their decision to make. But in the meantime, other people were trying to recreate it, and they have somewhat made open source models of it. So it didn't stop it. It just slowed it down a little bit. But then I believe Microsoft bought the license to that model. And Microsoft and GitHub then released this GitHub Copilot, which basically you give it a code comment and it generates the code for you.
Oh, wow.
In just about any language. But how they got that was by crunching up all the code on GitHub.
Right. I do remember this now that you mention it. Yes. Continue, though.
Yeah. So that's kind of suspect there. So people are arguing whether, that's, you can really use that. And, there's all sorts of interesting questions that are going to keep lawyers busy about it.
Right. What's a derivative work? And, in copyright law, right? That's an important term. And I read all the source code on the internet and then I made a thing. Is that a derivative work? I mean, I don't know. If it was a machine that did it instead, fascinating.
Yeah. So there have been people that pointed out, if you give it a certain prompt, it'll recreate code that is not open source, copyright. And of course, Microsoft didn't let any of their code be be scanned. That was closed source. So anyway, I guess they're gonna work that out or not.
So this is this is interesting, and it actually leads me to a question that I'm glad I thought to ask you, because I think your perspective would be great. So I don't really follow AI or machine learning, not really, but I've been interested in, just as a person who makes computers do things, and thinking about what the trajectory might look like. And so one of the things that you run into if you spend a little time looking into this is the notion of AI safety research, right? This for those that aren't familiar, if and when machines achieve human level intelligence or even beyond, which nobody can say for sure if that'll happen, but let's just assume for a moment that it does. What does that mean, for humans? And more to the point, like, shouldn't we be doing some work that makes sure that if there are choices to be made that we can make now that leads to a good outcome, I think to reduce it kind of to a ridiculous extreme, right? Like, wouldn't it be nice to have the robots just sort of take care of us, right? And like take care of our every need. Okay, great. If that's one outcome, and another outcome is, Terminator, right? Like, then how do we sort of steer things in the directions of the first thing? And so I would love to hear from someone who's, spends a lot of time thinking about machine learning, what your perspective is on the state of AI safety research, or the importance of it, or whether it's even really a thing that we should be worried. Just like that whole area is interesting to me.
I mean, it's a huge area right now. And actually, this trust in AI and in machine learning models is probably the one biggest hurdle that is holding back that in healthcare and health-related applications right now.
Do you mean that people don't trust them, or?
Yeah, just trying to figure out how to make them both interpretable. Like, if it gives you a wrong answer, can you even figure out why?
Right.
And trustworthy. I guess the analogy of the Iron Man suit. It should enhance humans, and rather than being just a separate thing that does its own, that sort of mentality. And safety, that you have safety checks in place as you go along, as you're training it, as you're developing, as you've deployed it, as you're reassessing it constantly. Is it still accurate? Is it doing the same thing that you originally trained it to, as the world of data changes around it, because it's not a static thing. There's totally interesting questions there, and also amusing failures. So another story from COVID that just came out, I think it was an MIT technology report that I saw this on, but they had tons and tons of COVID-related machine learning models, and a lot of people getting involved, and a lot of people trying to help, right? But they were doing so mostly just by like combining data sets and just plopping machine learning models onto data without really having a core understanding of that data and working with the clinicians, or the medical doctors, and where this was happening. And as a result, they did a huge study on some of the models that came out of this. And most models were not very useful, and some were just downright wrong. They had some models that had ended up, they were training it on some text, some optical text, and they picked up on the font that the hospital was using. So it associated the font with the hospital was using with high COVID cases with COVID. So if you were using that font, it would say, hey, you probably have a COVID patient.
I'm picturing like a really gothic, like curly, like ominous looking font. Well, yeah, I mean, come on. Like, if it says COVID in those lettering, well, of course it's going to be worse.
Yeah. So it's just, it's a tough problem. And people are taking a lot of time and tackling it. And there is a lot of promise. but it's the 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 risks of machine learning models and AI without putting thought into it is the worst case is garbage in, garbage out. And then you've got so much complexity, you can't tell what is going on. So,
Yeah.
yeah.
Kind of my favorite machine learning fail story is this is a while ago, and there's lots of these. This is just one that I liked. Was they had trained a model up to recognize pictures of wolves. So you could show it a picture, and it was pretty good. Like you could show a picture of a dog, and it would know that's not a wolf. Okay, that's pretty good. Until they realized that what it was really picking up on the picture was snow. Because there are so many pictures of wolves with snow. You showed a picture of the wolf in the summer, it's like, that's a duck. You know what I mean? Just like nothing. And yeah, so and there's a bunch of people that listen to this show that are not programmers. And so I think it's worthwhile to elaborate a little bit on the problem that you're describing. And I'm sure I'll do a poor job. You can correct me. But like the problem with these things is that when you or I sit down to write a piece of code in some programming language in the normal way, when we're done, there's a thing like a document, a text file that we can look at and point to, and we can understand all the parts of it, even if somebody else wrote it. Although that makes it harder. With machine learning, and actually it'd be interesting to hear you say whether this is still 100% true or whether it's starting to be different. We don't get that. What we get is like a big sort of. I guess you could think of it as like a spreadsheet full of just numbers, and you poke in, you type in some number up in cell A1. Then you scroll all the way to the right and down past millions of numbers that are all related formulas, right? Like in this huge tangled mess. And you go over to, ZZ 1078 and it says 7. And you're like, there's the answer right there. But there's no place where you or I as a human can look at that giant Excel spreadsheet with every cell connected to, 50 others, and numbers just percolate through and say, oh, there's your problem right there. So, first of all, have I sort of captured?
Yeah, that's good. Yeah, there are some new tools that have been developed that can help with that. For image recognition, you can kind of peer into the activation images, and you can see like a heat map what it's focusing on when it says leopard. Is it focusing on the snow, or is it focusing
on the spots? Yes.
Like what is it actually? And they have the same for like text. So if you're like looking at a sentence and you want to see if it's a positive sentiment or a negative sentiment, like I love ice cream sundaes. It probably highlight the word love for your positive sentiment. You can kind of debug it that way, but it's not. It's definitely not as straightforward as regular programming.
Yeah, which can be horrifically complicated. I mean, I'm sure you have, as I have, spent weeks attempting at one time or another to understand why a particular thing is happening the way it is in a body of code that is written in a language intended to be read by humans.
Yeah. Definitely. And then, just kind of going off on the different problems that you have. I mean, even if you've magically waved a wand and you've magically fixed all those problems. So you've got a model that's trustworthy. It behaves exactly like it should. It's great. So how do you then use that, like in the self-driving example of deciding where to swerve? That's us codifying moral judgments, which may not be the same for every culture and every country too. So it's just.
I mean, twins could differ on this, right?
Right.
Yeah, totally. Yeah, no, it's really interesting. I mean, this is not something that's unique to machine learning, though, right? Like we've had software that's needed to make decisions that are life and death before. I mean, oftentimes it's more clear cut, right? Like if the robot is swinging its robot arm towards somebody's face and it could know that, then it should stop. But
right.
I'm sure there are. I can't have one to mind, but I'm sure that there are examples of control systems that need to deal with that kind of ambiguity, and that where some engineering team somewhere has had to make a decision about how to encode those types of decisions. I think as the software gets more flexible, and of course, machine learning is a big part of that, right? Like dealing with inputs you've never seen before is part of the promise, right?
Yeah, I think it's always we've always had kind of decisions, but we haven't had them so potentially up in our face and with us every day. Like driving a car, you get into a Tesla car, that's what it can be doing for you. I mean, it's supposed to be doing auto assist, but there's so many videos of people. I don't know how they trick it. I don't have a Tesla, but they sit in the seat next to it and they have it drive them home or whatever. I don't know what they do, but
I was about to say, if the show ever gets really successful, Carin, I will buy you a Tesla. But I just remembered that the very first podcast we ever did, I said I will buy you a disco mirror ball, and I did. So I don't want to make any promises because clearly I'm obligated to keep them. So no promises on the Tesla.
Okay. Yeah. Well, I wouldn't mind. That would
I will say I'll keep you in mind, right? Like we'll see what we can do, but
I promise to only use it responsibly, though.
Okay. Well, I believe the show
trick out the auto assist
to date has made $1.47 in Amazon affiliate links, so we're still a few clicks away from a Tesla, but I'll let you know.
Well, that's good to know.
Anyway, I'm sorry to interrupt. You were saying very interesting things before I went off.
Oh, I know. I was just trying to think of. Just on my own kind of research, I've been kind of pivoting away from the really big AI models and that sort of area of research because I can't participate. Right there, I don't have the resources, and it's just too big for me. But I think just for the industry too, that there's been so much attention on the deep learning models there. And other people have said this too, that's only a small slice of the possible ways that intelligent and artificial intelligence systems can work. There are so many other approaches out there that need attention to and can be combined with the current systems or possibly better and more elegant than the ones that we have. So I'm kind of looking into the more esoteric ones right now.
I'd be curious if you could maybe give again, not an expert, like if you could give us an example of one of those and then kind of maybe explain what a deep learning type system is and then how it's different, that'd be great.
Yeah. So one of the things I'm interested in right now, it's got a cool name. It's hyperdimensional computing.
Isn't that cool? Sounds like a Douglas Adams chapter.
Yeah, yeah. But they also, I don't know why, but it's got like two names. So they call it hyperdimensional computing, and then maybe the name wasn't working. It wasn't like clicking with people, or maybe it was the other way around. But they have this other name, VSAs for it, or vector symbolic architectures. And the interesting thing about this is that it uses the curse of dimensionality, like high dimensional spaces. Usually it's really hard to do math and everything gets more complex to work in those dimensions. And they call it the curse of high dimensionality. And they turn this around and actually find this a blessing that there are some really interesting statistical properties that come out of working in vector spaces of, more than 100,000. So you could have vectors of, 1 million big. But the interesting thing that you can do with them is that you can pick, it's kind of confusing. My brain can only really visualize 3 dimensions. So, you've got like a vector and you've got magnitudes of the vector in like 2 dimensions. You can have a vector pointing
like the length,
in a certain
basically.
Right.
Yep.
And then you have, the direction of vector is pointing in like 3-dimensional space. And I'm cool with that, right? So that's 3.
Yep.
But then you can go to 10,000.
Yep.
And then you can go to 100,000. And the human brain, you can't really think of that anymore.
Not really, no. Actually, as it turns out, my master's thesis involved doing some linear algebra with 50-dimensional vectors. It was nothing as fancy as cursive dimensionality, but I had the challenge of like, okay, 40 dimensions. What is that? How can I think about that? It was a long time ago, though. Anyway, yeah. So that's 100,000.
Yeah.
All right. Yeah.
So
Crazy.
one of the
Brain
interesting
breaking.
properties of this is that you can just pick a random direction, a random vector,
Okay.
like your
Yep.
finger pointing in any direction in 100,000 dimensional space.
Yep.
You can pick any random one and then another random one, and it's nearly guaranteed to be orthogonal.
Yeah. Okay.
So you can do things with this of assigning vectors to be symbols. So an example, would be, you have one vector for like me, and then I could have another vector for socks, so I could say, and another vector for likes. So I could say I like socks all by doing the simple addition and multiplication. Everything is every noun and every verb is one of these vectors. You can add them together. Every time you do an operation on it, it's still another one of these vectors. And it's all encoded into just another one of these vectors. And then you can decode it.
I see.
So you're really encoding. You can code like a closure map. You could encode like a closure map in these vectors and then dereference them. It's just really cool.
How do you preserve order in that case, though?
That's very, very astute of you. So yeah, there is some tricks to actually doing order, and it kind of looks like linked lists.
Okay.
Yeah.
Wow. So I'm sure we just lost 99% of the audience, but that is okay because I still find this absolutely fascinating. So to summarize for those that might not have also those of you in the audience that did not happen to write their master's thesis on multidimensional mathematical stuff. Basically the idea is that we can represent everything as effectively a big long number. It's not quite accurate. It's it's got more than one dimension.
Yeah.
And then you can do operations on these things to combine them. Okay. And then the punchline is
you could do them all with just ones and zeros too.
Mm-hmm.
They can all just be binary vectors too, which saves you space. But yeah, so it's an interesting way. People have done research on it that you can use this as an alternative. In some cases, it's not as accurate to neural networks, and there's possibilities of combining it. So where you have where the deep learning systems really excel at being like function approximators, right? You could encode symbolic processing on top of it is maybe the potential for it.
Sure.
So it's really
gotcha.
it's really, and it's also very efficient and fast for how many dimensions it's working in, and deals with noise very well. So it's people are looking at it for robotics applications and just general research into
that makes sense
with deep learning,
because like you were talking about words, right? And those don't really look like functions, right? It's not like if I make a word one letter longer that it has to relate in any way to the prior word, right? Like I'm sure we could think of an example where you add one letter and the word becomes completely different. It's not a function where like a small change in the input means some corresponding understandable change in the output. It's actually like discrete things, symbols you were saying, that you're working with, and that this might allow you to combine those two approaches because am I capturing it at all?
Yeah. So
okay,
so some people have compared it to like neural network deep learning really excels at the bottom up kind of things where you're starting from like base images.
Yep.
And you're wanting to know, is it a bird? Sort of thing.
Right, yeah. I have an array of 10 million pixels. Some of them are red. Tell me if it's a bird. Yep. Okay.
But on the other hand, then you have the knowledge processes that we currently have in our computer science and every domain that are these like databases that you do queries on. And basically you're doing rule-based logic and Prolog queries on them. So combining those two ways of of knowledge would be very interesting.
And I assume at this point it's a research question as to whether that will play out or pan out or not. Like, what's this?
With that particular architecture, definitely, it's just an interesting thing to think about.
So Carin, I have to say, like, this is great. It's not meant. I mean, I'm saying this as a compliment. You seem to be drawn to, based on some conversation we've had, you seem to be drawn to things like this. And I'm trying to think exactly what I mean by that. Like, it almost seems like it's more appealing to you if very little is known for sure about the thing you're exploring. Does that make any sense?
Yeah. I mean, I guess I could have gone the research route in my career, but actually, I don't know. I think I have more independence right now. I've always heard people, maybe this is like sour grapes because I never went that route, but I do have a lot of independence that I can just change up what I'm interested in,
right,
and I don't need to, write papers or die, that sort of thing. But then on the other hand, I don't get a lot of time all the time to look into it. I mean, I have like two papers that I always like take my research papers and I print them out. I like the physical copy of them, and they hang out on my desk and I look at them and then I read them and then I look at them again. But I always like to have like the printout copy of them. So I have like a couple of them sitting here, and when I get some time, I look into it. But I don't have as much time as I want to. Maybe in the winter when I don't have to do so much of my garden.
Yeah, so this is a big thing for you, right? Gardening. And I think it's interesting to me because my wife's a gardener, and I feel strongly that gardening is also a making activity. You know what I mean? Like that there's something about it that is similar to, say, going into the shop and making large pieces of wood into smaller pieces of wood, or small pieces of metal into larger pieces of metal.
I totally agree.
Yeah, but what is it? Because I can't quite, because it seems like if you walk up to somebody and say, are they different? They'd say yes, but they would also say somehow they're the same, but I can't necessarily enunciate what the similarity is. What is it? Do you have an idea?
Well, I was actually thinking about this because I was like, well, what I've been doing, I haven't like been making anything, but I have been spending a lot of time in my garden, and my garden is mostly vegetables. Mm-hmm. So I'm making food.
Sure, absolutely. And that's what my wife likes to do too. And it's for her, it's like very distinct from flowers. Like she has people that the school, like she's doing a garden thing with the school, and some people want to grow flowers and she wants to grow vegetables. And she's like, no, vegetables are more interesting to me. Not that flowers are bad or whatever, right. But I'd like to dig in this a little bit more, because is it just that it is a thing didn't exist and now it existed, or is there some more? Because like I really did pick the name of this show, of the website, the YouTube channel. The Get Smarter and Make Stuff is very, like, it means a lot to me, and I think it's a thing that is real for other people as well. There is a mental and physical element to certain activities, maybe many activities, that the blending of those two things is important, right? And and I think maybe in gardening that's just it, right? Like, because I'm sure I'm not a gardener. I, like, my kids ask me, what type of tree is that? And my answer is, I don't know. Let's kill it and I can tell you, right? Because I'm a woodworker and I don't know what the insides of them look like. But so I'm not a gardener, but like I look at it and I go, that seems like the sort of thing that is the same as the things I'm interested in, right? Like there's a mental aspect to it. Maybe that's maybe one small question I could ask you. Is there a mental component to gardening that is important about the activity to you? Because I'm sure there is a mental component. Like, you have to think about how to do
I mean, I really got into it our last COVID year. I mean, during isolation and and all the craziness, anxiety that was going on. I mean, just going out and being able to connect with nature and taking care of something and like seeing it sprout. And finally you put all this time and energy into it and you get an ear of corn.
Mm-hmm.
It's just so beautiful when it works. But like working with analog machines, there's all sorts of world out there that you can't control. So you can't control when a storm comes and blows your corn down flat.
Mm-hmm.
You've been working so hard on it and come out the next morning and it's flat. But the cool thing about this, I realized, you don't have to stand it back up. It'll stand itself back up. It just like slowly like rights itself and it gets back up there. But there's all sorts of things, stuff comes in there and wants to eat your stuff in the garden too. I got to deal with chipmunks. I got to deal with rabbits. I got to deal with raccoons. um, and then knowing what grows well in your area, what is your particular soil type, what is your microclimate. There's just so many variables. How much time do you have to take care of it?
Mm-hmm.
There's all sorts of planning that goes into it. I think there's so many parallels that you could take from growing a garden in so many ways. You could take what you've learned to project management, to a software, how you write software. There's so many parallels and skills that translate, but at the end of the day, you have something tangible. You have a carrot. Mm-hmm. you have tomatoes that you can share with people. I really can't. I can't do that with my software that I write every day. I mean, you can share software, but most of the time it isn't as well received as a nice fresh tomato that you've grown.
Certainly, yeah, right. For sure, it's different. It's a different thing. I mean, food is very, like, that's pretty old, right? Like we've been doing food for millions of years, obviously, and software for slightly less of that. So I guess what I'm hearing you say, and I wonder whether you can speak to whether this sounds accurate, is at least one of a couple things. One is that there's a notion that a thing came to exist by your skill, right? So that's like a place I could see where I could say woodworking and gardening. In both cases, there's an object, and that object would not exist were it not for my efforts. So that's one thing. And then the other thing, and it sounds like you basically agree with that. Maybe you can comment more. But the other thing is, before I forget, is this is the get smarter. Like for me, it's that I acquired knowledge or a skill, right? And so that's like part of the process that I enjoyed. It's not just that I made a box. It's that, last week I didn't know how to make a box. And this week I know how to make a box. And I made a box as a way to acquire that, but like it's almost like the acquisition of the skill is an end as well. And this is sort of the get smarter and make stuff again, right? Like there's the object, but then there's also the effect on me. Does that resonate at all with you?
Yeah, no, definitely. I mean, it's. I'm sure to a farmer it would just be obvious, but for me, like collecting seed from my basil plant last year and then growing more basil plants from it, like that was just so cool. But I didn't know that before. I didn't know how to collect basil seeds and then save them for the next year. It sounds obvious and when you say it, but actually going through that process and doing it is very rewarding.
Yeah, it's an interesting thing that you say, because like I think I mentioned this earlier, even like a lot of us have a tendency to sort of simultaneously revel in the acquisition of knowledge. Like, oh, I'm so happy that I learned how to collect basil seeds. But then to at the same time say, oh, but other people already knew this. This is not new knowledge in the world. It's just new in my brain. And like I've heard, like I mentioned, that people come on and say, well, I'm no great woodworker because I can't make chairs or whatever. But I just find that tendency super interesting, right? And I mention it because it's a thing I want to be aware of in myself, right? To like so that I can be better at recognizing that I'm taking joy from acquiring the knowledge, even if it's knowledge that I'm the last person on earth to acquire. It's still super fun for me to acquire knowledge in a lot of cases. I don't know if that makes any sense.
It is. Yeah. You have to celebrate all the little things in life.
Absolutely.
And learning how to actually grow more basil plants, and they were free. like I didn't have to buy more basil plants. That was really cool.
I'm laughing. Yeah, go ahead. Yeah.
Yeah, I grew like 20, I could grow 30 more and they'd all be free except for my time.
Exactly. And I know exactly what you're talking about because like, whatever, I have a million hobbies and I make things that like could be acquired in a fraction of the effort to a higher degree of quality in many cases, quite easily. But I joke sometimes that at some point, it's not even really a joke, that at some point in the not too distant future around here, we will be sitting down to eat bread that was made by wheat grown on our property, ground with a mill that we.
Whoa.
We don't have plans to do this. I'm just saying, like, it would be served on a platter that was turned by me from a tree that grew on our property, baked in an oven from bricks that were clay that we dug out of the ground. You know what I mean? Like this sort of. It's not really homesteading exactly. It's more like we joke in the family that our family motto is Latin. It's possumus ergo faciamus, and apologies for my pronunciation, but the translation as best I can make it is we can, therefore we do. And
okay.
It's meant to be both aspirational, as in, like you can do anything, but also just sort of this like laughing recognition that, if something is possible, we're going to be like, what the hell? Let's do it. Right. Even if maybe we shouldn't sometimes.
Right.
Anyway, I sorry, I got super philosophical there.
That's good. I mean, we do the same thing. If we have vegetables, like I have the salad and I'm like, these are our tomatoes and our lettuce, but not our avocado. Enjoy.
Right. Yeah. Yeah, totally. So that's awesome.
One day I'll get a greenhouse and I can grow my own avocados too. But
awesome.
That's a way off in my dreams.
Well, we've always have someplace to go towards, I think, and that's probably a whole other show that we could talk about, kind of destinations or, story arcs, maybe. I don't know, might be a way to look at it. So many things. I guess, though, we are kind of coming to the end of our hour, and I don't want to like keep you too long. We'll just have to have you back on. There's more things I want to talk about, but I feel like if we start on one of them now, it's going to be another 45 minutes.
Most likely.
Yeah. So maybe, I always like to leave room at the end of the show because I don't want to say this is where we have to stop. Like if there's anything else that you think we should talk about today, or you think that we didn't cover enough, or anything else that makes sense to dive in, we don't have to stop right this second. So anything else we should talk about before we kind of start to draw down?
No, like I said, so we can save it for another time.
Sure, absolutely. We'll have you back on. Absolutely, for sure. Always super enjoy talking to you. Well, as I've said many times, I would be remiss if I did not take the advantage to ask the wonderful people that I have on this show who have so many interesting things to offer. If I did not ask them for a piece of advice, and this is, I always say it's to share with our audience, but who am I kidding, right? Like I want your advice for me. And so fortunately, I did remember to warn you that we would be doing this, although you're well familiar with the question since I stole it from the show that you and I each hosted at one point. But that question is, of course, what piece of advice would you like to share with me? Let's just call things as they are. I would like to hear your advice, Carin.
I love this question, and
okay.
I have personally learned so much from other people from asking it. But I will share with you. There's lots of things that I could say, but I'm going to go with the one that resonates with me most right now, which is just be kind to yourself. Over this past, year and a half, everyone has had such hardships, and a lot of people, including me, have had to take on like additional family responsibilities and just haven't had as much time to devote to getting smarter or making stuff. Right. And that's okay. You can give yourself time and space to have more time to do things at one point in your life and not, have your energy and time devoted to other things other times. And again, that seems obvious, but
no.
For people that always think, oh, I should be doing this and I should be doing this, just be easy on yourself and be kind on yourself, and it's okay.
Yeah, I got to say, this is a thing that I have been thinking about a lot as well. It's I'm trying to figure out how to put this. What you have said is super, super important, right? This is a thing. As that I've gotten older, I like to think I'm getting smarter. One of the things that I'm getting smarter about is me, right? Like, it's really important to get smarter about yourself because, you're stuck with you, right? And I'm not even sure what to say. Like, what you're saying, be nice to yourself, is so important because I think the default is not to do that, right? Like, we just, for whatever reason, as humans, it's our culture, it's psychology, it's something. It's very, very easy to not be nice to yourself, to hold yourself to a standard that you would never hold anyone else to. Certainly not somebody you liked, right?
Right.
And I'm just like really trying to express how completely strongly I agree with what you're saying and how very difficult it can be. And so it's really great to have that reminder. That's just super, super good advice. Yeah. Awesome. Wow, Carin, that was a good one. So thank you for that. I mean, that's great, but thank you for the whole conversation. I mean, I knew we'd have fun. It certainly was. I hope that we can have you back on before too long and talk about some of those other things and hear more about your various adventures. But thanks for taking the time today. It's been great.
Yeah, it's been very enjoyable. So thank you for having me on.
Awesome. Well, I hope everybody else enjoyed that and took it as a little bit more inspiration to get smarter and make stuff. Talk to you next time. You have been listening to Get Smarter and Make Stuff. I'm your host, Craig Andera. Visit the show online at getsmarterandmakestuff.com. That's all spelled out, all one word. Go there to subscribe to and comment on the show, read the blog, view the gallery, and find a link to the Get Smarter and Make Stuff YouTube channel. Come on by. We're also on Twitter at MakeSmartStuff. If you enjoyed the show and feel like sharing with others you think might like it too, I'd certainly appreciate it. Thanks for listening and see you next time.